Okay, now let's quickly go over the last two slides. And so here we are going to test the more general hypothesis in a regression coefficient. So we are not testing if it is equal to 0 anymore. We want to test if it is equal to any number. It's equal to aj. Again, this is just is a cosmetic thing. I call it aj. So for instance, beta education is equal to a constant of education. Beta age is equal to a constant. Okay, it really doesn't matter. You call it AJ, AI, whatever. It's a number. This is a number. And you want to test that. How do we test that? Our test statistic, everything is exactly the same. This is your estimate, beta hat j minus hypothesized value, beta j under the null, and divided by standard error. So this is our standard error of beta hat j. So it used to be beta hat j minus 0, now it's beta hat j minus aj. That's the only difference. And the rest of it is exactly the same. The test works exactly as before. So except the hypothesis value is subtracted from the estimated one in the numerator, right? So here. Okay, let's look at an example, and we will see why sometimes we're interested to test it against a number different than 0. So here's an example: campus crime versus enrollments. Imagine we're regressing log crime on log number of enrollments, right? And this is log model. It's constant elasticity return. Well, it's suggesting constant elasticity return, right? And let's say I'm interested to say that if 1% increase in enrollments will lead to exactly 1% increase in crime. If that's the case, our null hypothesis is going to be this. So let's read through it. An interesting hypothesis is whether crime increased by 1% if enrollment is increased by 1%. Okay, you want to test that, if that's the case in the entire population. How do you do that? So let's construct the t-stat. 1.27 minus what? The population parameter under the null, which is 1, divided by here. This is our hypothesis, right? And it's 2tail if it is not equal to 1, divided by standard error 0.11. So what do we get? Number is 2.445, and we compare it with the critical value. Let's say the critical value is 1.96. I'm using those rule of thumbs because, well, maybe the number of observations is not that small. So 2.45 is larger than that, so we reject the null. So the hypothesis is rejected at 5% level. So this means that we reject the idea that the effect of enrollment on crime is 1 for 1. So we reject this idea. It's different. What is that exact number? We have no idea. In this one sample, it was 1.27. In another sample, maybe it's 1.3. In another sample, maybe 1.26. What is the exact number? We never know. All we care is that it was not 1 for 1. Okay. Important, this t-stat is different than what is reported by statistical packages. Okay, this is also very important, guys. Remember, if you run this regression in R, and then you look at the output, if you see something like this, these numbers, these t-stats are calculated when your null hypothesis is equal to 0 and alternative is not equal to 0. If you want to test it against a specific number, 1, 2, 3a, you cannot rely on these numbers. So basically, you have to calculate the t-stat. So, in short, you cannot get this number out of R. So you have to manually construct this. All right, so let's call it a day. I know it was a long one, but at the same time, it was a very important one. And the reason that it was a little long because we had to go over some reviews from statistics course. Good luck and see you in next class.